Well, thank you very much for inviting me here. I've had the pleasure of working with many, maybe not quite all of the member agencies here and some of the folks in the room, and lots of great engagements with the working groups that are organized under NITRD. What I wanted to do is give you a very quick overview, just in case there isn't anybody, there's somebody here who doesn't know about the academies. I'll say just a couple words about that. Introduce CSTB, who we are, what we do. And then I thought I'd go through a few examples of some recent work and some of the impacts that that's had, and kind of run through our current portfolio of activities, the studies and other things we have underway, and some of the things we're thinking about. And then I'll leave, I guess we have about 40 minutes, try to leave some time for questions, and feel free to interrupt me along the way. This is kind of interactive. This is for your benefit. Okay, so the academies been around since the 1860s and chartered from the outset both as an honorific organization to honor the top talent in science, engineering, and medicine, but from the start to an advisory function for the federal government and the nation. And in fact, the academies have played that role throughout that history. Today, the three academies in sciences, engineering, and medicine, collectively we have the very simple name, the National Academies of Sciences, Engineering, and Medicine, which is kind of how our operating unit and our external brand, if you will. And it's a fairly large enterprise today. We put out a report basically every business day of the year and involve something like 10,000 volunteers at any given time in our activities. So it's a pretty large thing, sort of covers almost any topic you can imagine in science, engineering, and medicine. Just very quickly to give you a sense of the organization structure, our programs are divided in part into sort of things that would seem familiar in a college or university, divisions covering behavioral and social sciences, earth and life sciences, engineering and physical sciences where I sit, health and medicine. We have a unit that looks at sort of broad public policy issues and international issues, and then large specialized programs, one in transportation. It turns out we do a large amount of research in transportation on behalf of DOT, but also the state transportation departments. And we have a new program that does work on mostly sort of environmentally oriented research in the Gulf of Mexico region. I sit within the Division on Engineering and Physical Sciences. It has a number of boards that are focused around disciplines from aeronautics to space to physics and, of course, computer science. We also have 3 boards that have special relationships with the military services and a new board that works closely with the intelligence community. And then we have a specialized board that does ongoing assessments of the NIST laboratory programs and also the Army Research Lab. Well, what does a board do? One thing is we provide kind of a base of expertise within the national academies and sometimes make sure that computing issues are always fully acknowledged and addressed. We foster interaction among the fields. Computing, communications, information technology is a broad field, and also interactions with the wide range of disciplines and professions that computing and IT touch. We provide a sounding board for sponsors, other federal agencies, and other stakeholders, discussions at CSTB meetings. We've also put together a forum focused on cyber resilience that meets 3 times a year, focused in that area, and those discussions are another sounding board and discussion opportunity. We're charged with monitoring and promoting the health of the computing and communications disciplines. That includes things like human resources. We initiate studies where we see important national challenges, and we respond to requests. Those requests mostly come from the federal government and mostly from the executive branch agencies. But some of our work is commissioned directly by Congress through legislation, and we do some work with nonprofit organizations. And the board's final role is kind of oversee activities, make sure that the activities that we launch are well conceived, make sure that we've got the right people involved in them, and so forth. Just to give you a sense of membership, we try to have a pretty good cross-section in both academia and industry, and a wide range of disciplines on the CSTB itself. And then, of course, our committees have sort of people of comparable expertise and stature, and tend to cut across even a wider range of disciplines appropriate to the particular topic. To sort of give you a sense of our portfolio, I went back over about the last 5 years just to give you a flavor of the different topics, and I sort of see 8 themes there. One is we do sort of research agendas and programmatic issues related to research. One of the subthreads there is advising on strategic directions and best practices related to research cyber infrastructure. One of the newer areas we've been working in is sort of new directions in computing education, whether it's how to respond to the surge in undergraduate enrollment in computer science, the emerging fields like cyber physical systems engineering, envisioning data science as a field. Oh, yeah, that's next. So number 4 is a variety of work explaining how communications and technology arises, evolves, the role of R&D and the different contributors. I think Jim just held up the brochure of the tire tracks diagram, which is one of the key products there. Some of our work is really digging in deep on emerging technologies and explaining to a broad audience, including policymakers, what's really going on here, what are the implications, and what does it mean. So, for example, wireless technologies, biometrics, authentication. Lots of work responding to the cybersecurity challenge. I mentioned we have an ongoing forum that explores these topics, and I'll just skip ahead to something like 25 years of work. Like I said, we've been doing this long before it was fashionable. The depressing thing, of course, is that we continue to struggle with some of the things that we pointed out 25 years ago. And another area, periodically, we're asked to do reviews related to the use of computing by the federal government, modernization programs, strategy, and so forth. And recent engagements have been with the FAA, Medicare, Medicaid, Social Security, and so forth. And so every couple of years we tend to do one of those. And the last area I'll mention is we work on some of the complex public policy issues that come up related to computing. We're collaborating within the academies on a study looking at voting technology, encryption debate that's heated up again. We have a project on that. We, a couple of years ago, did a project looking at policy, looking at the technical options, technical alternatives to bulk collection of telephony metadata. So some nice, simple, straightforward, non-controversial topics. We're maybe best known for consensus studies. These are intensive activities that might involve a dozen or 15 experts, half a dozen meetings over the course of 18 months, and often come out with recommendations, or sometimes we might not make specific policy recommendations, but at least carefully illuminate the policy options and perhaps some of the principles that should guide policymaking or questions that policymakers should ask when trying to make policy in that area. But we also do a number of different convening activities. We organize workshops, roundtables, and sort of one-off expert meetings where federal agencies want quick access to a set of experts, want our help in gathering those people together, and to sit down and have a conversation about a hard problem. A pretty wide array of sponsors. A number of the agencies represented here, as well as a number of other agencies. That first group are the agencies that have been sort of the most frequent sponsors, have sponsored many activities over multiple years. And then there are a number of agencies that have had 1 or 2 offs over the years as topics have emerged of interest to them. Let me run through it. Any questions so far? Okay, let me run through a few examples and give you a little bit of a flavor for some of the stuff we've done and how that ends up getting used. I guess last year we issued a report that NSF had asked for, looking at future direction strategy for NSF's advanced computing infrastructure programs. We ended up framing that as recommendations to achieve 4 broad goals, which I'll let you read here. And one of the key points that came out of this study was that expertise and physical infrastructure are an essential part of advanced cyber infrastructure, and they have a longer lifetime than the particular computer that you might acquire at any given point in time. And that point got picked up, in fact, in the recent program solicitations. And next we were able to be helpful to sort of reinforce that point in that program announcement. And then a number of our activities, in part or in whole, are about framing research agendas and identifying emerging areas. And 3 examples here: a report looking at computing research for sustainability that was used in framing the NSF's program, work that we did for the Office of Secretary of Defense around software producibility that ended up getting picked up, I think actually by the Air Force program, and I think one of the other services also used that as part of the framing of a new research program. And then a few years back, we looked at the challenge of continuing to improve computing performance, our Game Over or Next Level study, and among other things that was used to stand up a DARPA program. Another recent study looked at the impact of automation, IT more generally, on work in the U.S. workforce. And this quote, I think, sort of sums up the whole message from the report. The ultimate effect of these technologies are not predetermined. Rather, like all tools, information technology can be used in different ways. The outcomes for the workforce and society at large depend in part on the choices we make and how to use these technologies. New data and research advances will be critical for informing these choices. I think that encapsulates sort of an important message about this phenomenon. And we were able to get that out in a variety of ways. The comment piece in Nature was a way of reaching the broad S&T research community with those points. And we're also, this was the sort of thing that also got picked up by New York Times and other media outlets, sort of bringing this message more broadly to the public and to policymakers. The tire tracks figure, I mean, it's really been a powerful tool for illustrating the impacts of IT research and explaining the government university industry innovation partnership. And so I think the figure is often used by people trying to tell this story. And we also have tried to capture some of the sort of broad lessons about that partnership. Things that I think we all know but are helpful to keep saying and explaining and giving examples of that unanticipated results of research are often as important as the anticipated ones. The role of this partnership, the essential role that the federal government plays, and the enormous economic payoffs of that research. I think this is my last example. The Cyber Resilience Forum has convened probably dozens of conversations about cybersecurity topics over the last couple of years. 3 of these have been sort of more intensive workshops. One really highlighted, and I think we did this in the period between the OPM breach but before the Equifax breach, but really talking about the challenges of data breaches and the real dearth of mitigations available to respond to these, and really painting that picture compellingly. A second one looked at cryptographic agility, what's involved in responding to something that requires a change in the cryptographic algorithms or protocols that we use, whether it's the responding to quantum computing capabilities or the discovery of a flaw in a cryptographic algorithm or in a crypto protocol, and just how really hard and complicated it is to convince yourself you've got something that's a suitable replacement and get that deployed in the real world. This is a long process, and there are many stories of the pitfalls that are involved in making these transitions. And when you get snarled up in things like whatever degree of backward compatibility you have to maintain while you make the transition, and the security problems that result from that. And the most recent of these looked at the role of software updates in achieving security, and of course it's sort of this double-edged sword. You need to update things to deal with identified security vulnerabilities, and at the same time, if you don't do this carefully, you open up another attack surface. And let me talk about kind of what's in the current portfolio. One of the things we're doing is looking at data science. What does this field look like? What's the intellectual content of it? And what should we be teaching undergraduates about it? It's an envisioning exercise. There are obviously lots of interesting points of departure today as various institutions are experimenting with programs of various sorts, and it's a very fast-moving field. And so we're trying to capture a sense of where the field is going and what an undergraduate experience might look like in the future. I mentioned the project on the future of voting technology. This actually was conceived of well before the 2016 election season, and the sort of more mundane questions we were looking at addressing were how to deal with the technology refresh that's going to be needed as all the stuff that was purchased in the early 2000s after those election problems is starting to become obsolete, and there really aren't mechanisms in place to do that technology refresh, and lingering questions about what are the right sets of technology choices to be making in the future. This obviously has become a more complicated topic in light of recent events, and so some of this is going to be focused around how do we respond to some of the security challenges and more broadly, the assurance and confidence issues that come up in elections. That's to be sort of midstream and due out in spring of next year. We're just wrapping up a study on the problem of, what the FBI and other law enforcement would frame as going dark, as encryption is becoming widely available and a default in many devices and services, the challenges this presents, the challenges that exceptional access mechanisms to afford government access introduce. We're not going to give an answer to this question. It's not clear there is no simple answer to this question, but rather a set of questions that you should use. If somebody comes forward with a policy proposal or a technical proposal, what are the questions you should ask to evaluate that to satisfy yourself that it is a reasonable proposal and addresses the trade-offs in a sensible way. We're also doing an assessment of kind of the future of quantum computing. What's feasible to do in the future to build a practical quantum computer? What does practical quantum computer mean in different contexts? What are the implications? Sort of implicit in there is a little bit of a cost-benefit analysis from a national security perspective. You could race ahead and build one of these and discover that some of the applications you had in mind, if you were trying to break crypto, that you might not keep up with progress in quantum-resistant cryptography, for example. The interesting feature about this study is it's sponsored by the intelligence community, but it's completely unclassified. So it's really an effort to establish what can you say about this topic from a completely open science perspective. We'll be wrapping this up in early spring. And the last thing I'll mention is we're doing an update of TireTrax. I think the last sort of full look at this we did was in 2012, and I think a lot's happened since then. A lot happens every year. So we're going to try to update that with some of the new developments, some of the new emerging areas, and also we'll see, this is going to be a bit of an experiment to paint a picture of not only the things that have turned into billion-dollar and $10 billion industries, but a bit of a sense of what are the things that seem poised to head in that direction, to give a bit of a sense of that forward-looking picture. And just mention some of the topics we're exploring right now. One is we've reflected a bit on, there seems to be a little bit of, maybe a little bit of discord between sort of the view you might have from wearing a cybersecurity hat with some of the perspectives we've heard from people who are responsible for the electric grid. about just how serious the cybersecurity situation is, whether we're taking all the necessary steps to protect ourselves, and so forth. And so we're actually talking with DHS right now about a workshop that would kind of take stock of where we are and make sure we're sort of all on the same page about what the challenges are and what the responses should be. Another cybersecurity topic is, there are lots of people who work in cybersecurity who aren't purely technical. They're in policy positions, management positions, governance positions, and one of the interesting questions is, well, what should they learn about to be cybersecurity professionals? How much of a technical background do they need? And actually, there are quite different perspectives on how deeply technical such people need to be. There are a number of different programs being stood up, master's level programs sort of in cyber policy. We wanted to look at sort of what are the best ideas out there and bring people together to share different ideas. Two other cybersecurity topics. One is there are interesting challenges as we're introducing various AI techniques into safety critical and other highly critical systems. Just to mention one issue, sort of the paradigms we have around certification, I think are challenged by systems that are constantly learning and changing. And of course, AI capabilities create all sorts of interesting new attack surfaces from a security perspective. And given how quickly we see systems getting ready for deployment in the real world in safety critical situations, it's an interesting time to look at, well, what do we know, what are the unknowns here, and how do we move forward. And a topic that's been on our radar for quite a long time is cyber attribution and public trust. So there are clearly events that happen where there's a need to convince a broader set of individuals and perhaps the general public about who is responsible for a particular cyber event, how did it happen, and what kind of evidence can you bring forward to the general public? It's often highly technical. The sources and methods are highly sensitive. Attribution is not a purely technical exercise, and so it may involve very sensitive non-technical sources. But nevertheless, there's an important challenge here in bringing this kind of information to the public. And I think we've seen some challenges with recent attribution efforts in terms of what kinds of evidence could be brought forward and what kinds of evidence we're convincing and so forth. So I think this is an interesting topic. There's this ongoing question about sustaining improvements in computing performance. What are the sort of the paths we're on are either things that have limits or are very difficult, and what are future directions and paradigms for computing. Another topic in thinking about it, we actually 15 years ago did a project that looked at, well, what should every undergraduate know about computing? And excuse me, this is a very different question today. Computing has changed a lot. It's computing in data and a wider set of things, and I think it'd be quite interesting. And of course, there are various experiments going on at universities to try to teach. It's going to be very interesting to look at intellectually what are the things that we would expect every undergraduate to know. An interesting variant on this that came up at the last CSTB meeting is professions, take medicine, is likely to transform significantly as a result of computing. What should medical education look like in light of those sorts of developments? So that might be another way to approach this topic. And that actually brings to mind the last topic I'll mention. We've been exploring with our colleagues in the health and medicine part of the academy, trying to really dig into what are the implications of AI and other advanced computing for healthcare. And there sort of seem to be major transformations possible as computing capabilities can replace, perhaps, maybe even outperform certain tasks that doctors perform. How will AI in the future complement what medical professionals do? And so that's something we're actually gathering together, a planning group, sort of half computer scientists who have been exploring this, and then some people from the medical community to kind of lay out what are some of the interesting questions. And so this may turn into a future study activity as well. And let me stop with the question I always like to ask with a group like this is, what else should we be doing? What's important to you? What do you see as important to the nation that we should start thinking about? And feel free to reach out to me with ideas. And lastly, CSTB.org has all of our stuff. You can read everything that we've done there, and keep track of our activities. And there should be a link there to subscribe to a newsletter. We will not spam you frequently. We'll just send you a few emails a year that give you information about new publications that have come out, new studies that we're doing, and events that we're holding.